So how do we show that a set is a subgroup of a group? Well, here we have our primary group, which is the real numbers and our operation is addition. And here we have our set, where we have log of a, and a is inside the rational numbers, and a is greater than 0. So how do we show that this is a subgroup of this? Well, in order to do that, we need to show that this fills two pieces of criteria. One, it needs to be closed with respect to addition, because that's our operation, right? And two, it needs to be closed with respect to negatives, all right? So let's start with showing it's closed with respect to addition. So how do we do that? Well, we're going to let a log x and a log y be inside the set H, all right? Then what we want to do is we're going to add those together, and we want to show that if we add those together, it's still inside this, all right? So then log x plus log y, right? From our properties of logarithms, we know that log x plus log y can be turned into log x times y, all right? Now we have this. So now what do we do from here? Well, we need to now show that x times y is in fact inside, or is rational and greater than 0. Well, what do we know from here? We know since log x and log y are both inside H, we can conclude that x is rational and greater than 0, and y is rational and greater than 0, right? Now that we know that, if we multiply something that's both rational and greater than 0, two things of those times each other, that'll just produce another thing that is rational and greater than 0. So we can therefore conclude it is closed with respect to addition. Now we want to show that it is closed with respect to negatives. So once again, we're going to let a log x be inside H. All right. Now we want to show that negative log x, I'm going to add parentheses, is inside H. All right. So what do we know about negative log x? I will get rid of this for now. What do we know about negative log x? Well, we know it can be simplified to log of x to the negative 1, which is also log of 1 over x. All right? Now let's go back to what we assumed from the start, that log x is inside H. If log x is inside H, that must mean x is rational and greater than 0. If you take the reciprocal of something that's rational, you still have something that's rational, right? And since it's greater than 0, it'll remain greater than 0. So we can conclude it is also closed with respect to negatives, and therefore this is a subgroup of this, and therefore this is a group with the operation addition. Thank you for watching. Let me know if I say anything wrong or if you have anything additional to add. Have a great day.